Good morning, all of you. So, in last class, we have discussed the definitions and concepts of the differential equations. So, now we'll discuss the applications of the ordinary differential equations. So, first one is Newton's law of cooling, and second one is we'll discuss here the law of natural growth and decay. So, first one is Newton's law of cooling. Newton's law of cooling. It states that rate of change of temperature of a body is directly proportional to difference between the temperature of body and at that surrounding medium. The rate of change of temperature of a body with respect to the time t is directly proportional to difference between temperature of a body and at that surrounding medium. So next here, d theta by dt is equals to minus k of theta minus here theta naught, where k is a Newton's law of constant. The temperature is decrease, so that's why I took minus k. Now d theta by, I'm going to solve this differential equation by variable separable method. So theta minus here theta naught is equals to minus k into dt. Apply integration on both sides. Now here integration of d theta by theta minus theta naught is equals to, now integration of here minus k into dt. So next, log of theta minus here theta naught is equals to minus kt. Next place log c. So or we can write here theta minus theta naught is equals to e power minus kt plus here log c also. So this one is equal to, we can write e power minus kt into e power log c. So next one, e power minus kt, c is a constant, log c also constant, e power log c, it is also constant. So I am taking capital A, where capital A is equal to e power log c. So theta is equal to what we can write? Theta naught plus here a into e power minus kt. So this is a Newton's law of cooling. Log of theta minus theta naught is equals to minus kt plus log c. Okay. Next we'll solve one problem, how to apply the Newton's law of cooling statements. So what we will calculate. So in the first day, you have been introduced one application. The temperature of a cup of coffee is 90 degrees Celsius. Yes. The room temperature is 24 degrees Celsius. In 1 minute, the temperature of a cup of coffee has been decreased to 80 degrees Celsius. Next, what about the temperature of a cup of coffee after 2 minutes? 2 minutes. What about temperature of a cup of coffee? Yes. Now by Newton's law of cooling, by Newton's law of cooling, here, have you understood the question? Look at here. This is an initial temperature of a cup of coffee is 90 degrees Celsius. In room temperature, we kept a cup of coffee of 90 degrees Celsius. I kept in the room. Okay. After 1 minute, I observed the temperature of a cup of coffee. It has been decreased to 80 degrees Celsius. Okay. Here we need to calculate after 2 minutes how much temperature has the cup of coffee. Now, here the room temperature means that this is the constant temperature. Is room temp. Now this is a theta naught because of, now write the Newton's law of cooling. Here log of theta minus theta naught is equals to minus k into t plus log c, where theta, what theta? Theta is a temperature of an object. Theta naught is a room temperature, means surrounding medium or constant temperature. T is a time, k is a Newton's law of constant. C is an arbitrary constants. Here, first initially temperature of a cup of coffee. So theta is equal to 90 degrees Celsius, and initially the time will be 0. If assigned as an equation 1. Now substitute here log of theta minus theta naught. Theta naught is 24 degrees Celsius. This is our room temperature, right? Now 24 is equals to minus k into t. Minus k of here t will be 0. Initially we'll take consider as a time 0. Next place here log c. Better to write here the temperature of a cup of coffee is 90 degrees. So I've substituted here 90 degrees Celsius. Clear? Just I've substituted temperature of an object, means temperature of a cup of coffee, theta initially, and t is equal to 0. Yes, now we are 90 minus 24. So you get the 66. Log of 66 is equals to log c, or c is equals to 66. So next, after 1 minute, means at the time 1 minute, the temperature of a cup of coffee has been decreased to 80 degrees Celsius. Yes, it has been decreased to 80 degrees. Now substitute in equation 1. Log of theta 80 degrees Celsius minus theta naught. Theta naught is always 24. Yes or no? Yes. Is equals to minus k into t. So minus k of t is 1 minute. Next place log c. What is log c? Here we get log 66. Log 66. So log of 80 minus 20, 80 minus 24, 56. Yes. 56 log of 56 is equal to minus k plus here log 66. So here k is equals to log of 66, log 56 sent towards the right side. We get here log of 56, log a minus log b, log a by b. So log of 66 divides here 56. Yes. So next continuation, to find the temperature of a body or temperature of a cup of coffee after 2 minutes, right? So here after 2 minutes means here time t is equals to 2 minutes. Theta, here we have to calculate the temperature of a cup of coffee. Theta we don't know. Now substitute in equation 1 again. What we will get observed here? Now log of theta, we don't know theta, we need to calculate the theta. So just write like that. Next one, same as this theta minus theta naught. Theta naught is temperature of a room temperature is always same. So now the temperature is 24 is equals to minus kT. So k value is log of, now here it is log of 66 by 56. Next place log c. Log c is equal to log 66. Log 66. Now log of theta minus 24 is equal to log a plus log b. Log a into b. We get here 66 by 56 into 66. So theta minus 24 is equals to 66 by 56 plus here 66. So we get the temperature of a cup of coffee after 2 minutes. We get 24 plus 66 by 56 into 66. You will get the temperature of a cup of coffee after 2 minutes. So next we'll discuss one problem is related to the law of natural growth and decay. So what is law of natural growth and decay? Law of natural growth and decay. Here, if the rate of change of a quantity x at any instant time, here it is t, the rate of change of a quantity x with respect to the time is directly proportional to the quantity present at the time is equals to x. So the differential equation of growth is dx by dt is equal to k into x, and the differential equation of the decay dx by dt is equals to minus k into x. Now solve this equation. I'm going to solve this differential equation by using variable separable form. Now dx by x is equals to k into dt. Now apply integration on both sides. I'll get here dx by x is equals to integration of k into dt. Already we know very well about the integration of dx by x is equal to log x is equals to k into t, right? Kt plus take some arbitrary constants log c1. So here log x is equals to, we get kt plus log c1. So this is the solution of the growth of a differential equation. Next, decay of the differential equation, take as it is a minus kt. So it is growth means increasing, decay decreasing. Dx by dt is equal to minus k. Yes, we can solve like previous method. So we will get solution of the decay of the given differential equation. So let's see the example.